Hey, good everybody here. We're going to be learning section 7.2 and in particular how you use the converse of the Pythagorean theorem. Now that you know the Pythagorean theorem is an if-then statement, not just an equation, we're going to talk about how you take that if-then statement and write the converse of it and how you apply that to various situations. In particular, the skill that I need you to have today, I need you to be able to use the side lengths of a triangle in order to determine whether the triangle is acute, right, or obtuse. Now, normally you have to know the angle measures in order to determine which kind of triangle you have, don't you? But it turns out you can use the side lengths, if you know all three of them, to determine whether you've got an acute, right, or obtuse triangle. And we'll get to there. First, let's recall what the Pythagorean theorem is, and then we can talk about what the converse of the Pythagorean theorem is. All right, I'm kind of paraphrasing here a little bit. But remember what the Pythagorean theorem, you first of all have to know that a triangle is a right triangle. So if a triangle has a right angle, I'll phrase it that way, then we know the square of the hypotenuse equals the sum of the squares of the legs, or we use the equation c squared is equal to a squared plus b squared. Well, remember, whenever you're trying to write the converse of a statement, you simply switch the hypotenuse with the conclusion. And so what that would mean is this. The converse of the Pythagorean theorem would say that if c squared equals a squared plus b squared, then a triangle has a right angle. There, you see that? Okay, so in other words, we can use the sides of a triangle in order to determine if it has a right angle or not. And all we have to do is do the three side lengths come in the form such that the square of the longest side equals the sum of the squares of the two smaller or shorter sides of the triangle. So how do we use that? Let's use that to determine whether these triangles are right triangles or not. Look at part A to begin. We want to know, does this triangle have a right angle? Is it a right triangle? And so what we need to do is we need to determine, well, first of all, if it is a right triangle, which side would be the hypotenuse? All right, and hopefully you're always going to pick the largest one for that, because the hypotenuse has to be the longest side of a right triangle, doesn't it? And so then what we want to do is we want to see, is 42 squared equal to 30 plus 36 squared? All right, now 42 squared is 1,764. 30 squared plus 36 squared is going to give you 900 plus 1296, which is equal to 2196. So, since c squared is not equal to a squared plus b squared, all right, this does not match up with that. It's not a right triangle. Now later on in the video, I'll teach you how you can take that same triangle and determine, is it acute or is it obtuse. It's got to be one of those if it's not a right triangle, correct? All right, so then part B, same idea. We're going to try to take these side lengths and see, do they form the side lengths of a right triangle. Now, going back to what I said in the previous one, where you want to make sure you choose which has to be the right angle, and you can't always go by the way the picture looks, you have to go with the longest side, don't you? Do you know whether 8 square root of 3 is larger or smaller than 16? Well, the square root of 4 would be 2. And then if that was 8 square root of 4, then this would be 16. 8 square root of 3 then has to be less than 16, doesn't it? All right, so the C is going to be kind of what it looks like it would be right there. 16 squared then, we'll want to know that. That's 256. And then we want to do 8 squared plus 8 square root of 3 squared, and see what that gives you. Well, pay special attention to this. I know you know 8 squared is 64, but I don't know if you know how to square a number that has a radical and a coefficient. But the way you do that is you simply square each factor here. That becomes 8 squared times the square root of 3 squared. All right, now 8 squared is 64. The square root of 3 squared is 3. So we've got 64 plus 64 times 3. 64 times 3 being 192. And 192 plus 64 is 256. So you can see indeed that our c squared was equal to our a squared plus b squared. So yes, that is a right triangle. All right, you see how that works? Now let's take a look at how you modify that in order to determine if a triangle is an acute or an obtuse triangle. Okay, now what I've done here is I've drawn 3 triangles that have 2 congruent sides, and I'm going to be referencing the hinge theorem, if you recall that from chapter 5, as I go through this little set of examples to show how you know this, based on the sides, what kind of triangle you've got. Okay, and what I'm going to do is I'm just going to label the third side as C on each one of these. Now, we know that in a right triangle, c squared is going to have to be equal to a squared plus b squared, or in this case, c squared would have to be equal to 8 squared plus 10 squared, right? In order for that to be a right triangle. Okay, now, what happens as I take the hinge angle right here and I decrease that hinge angle? And what I mean in particular is what happens to the value of c as I decrease this hinge angle right there. Now, if I decrease a right angle, I'll make it into an acute angle, so that would be making this picture right here. Well, doesn't this side have to be less than this side had to be? Okay, so here, if c squared had to be equal to 8 squared plus 10 squared, but here I've made c smaller, that suddenly means that c squared has to be less than 8 squared plus 10 squared. Does that make sense? And so just in general, a triangle is acute whenever c squared, the longest side squared, is less than the sum of the squares of the 2 shorter sides of the triangle. Notice I didn't use hypotenuse or leg because that doesn't apply to an acute triangle. All right, and we already said that if c squared equals a squared plus b squared, you've got a right triangle. Any guesses as to what the case would be for an obtuse triangle? Well, if I take that hinge angle again and I increase it, in other words, make it from a right angle to an obtuse angle, doesn't the effect on the third side have to be that the third side is longer than it was before? And so if c squared used to be equal to 8 squared plus 10 squared, but now it got longer, then that means c squared is going to have to equal 8 squared. Sorry, it's going to have to be greater than 8 squared plus 10 squared. And just generally speaking then, in any obtuse triangle, the longest side squared is going to be greater in value than the sum of the squares of the 2 shorter sides of that triangle. So, these are the 3 facts that you need to know right here. Boom, boom, boom. And let's put those into action. I've given you 3 sets of segment lengths here, and I want us to decide if the segment lengths form a triangle, first of all, and if so, would the triangle be acute, right, or obtuse? Well, let's scan these and see if we can determine if any of these side lengths don't form a triangle. Remember, in order for a set of numbers to form the side lengths of a triangle, the sum of any 2 sides has to be greater than the length of the third. Now, in each one of these cases, we're going to let the greatest side be our side C. All right, so the 9 would be the C there. 12 square root of 2 would be the C here. That's greater than 12. Hopefully that's fairly obvious. And 15 would be the C there. And so if A plus B is greater than C, then you've got a triangle, don't you? Well, here, 7 plus 8 is greater than 9. So that is a triangle. Here, 12 plus 12 is 24, and 24 is greater than 12 square root of 2. That is a triangle. Here, 8 plus 5 is 13. 13 is not greater than 15, is it? So we don't care about whether this is an acute or an obtuse triangle or a right triangle, because it's not a triangle at all, since 8 plus 5 is not greater than 15. Okay, but the other two are triangles, and so we can say, yes, they are triangles, but then we need to figure out which kind of triangle they are. And the way we're going to do that is we're going to compare the values of c squared with the values of a squared plus b squared. So c squared here would be 9 squared or 81. A squared plus b squared would equal 7 squared plus 8 squared, which is equal to 49 plus 64. And that's 113. And so what we need to do is decide, is c squared greater than or less than the sum of a squared and b squared? And in this case, here are the two values we're comparing. There's c squared, there's a squared plus b squared. We're going to say then this is an acute triangle, aren't we? And the reason we know it's an acute triangle is because c squared is less than a squared plus b squared. All right, part B. I want to see what you can do with this now that I've already shown you in the previous slide how to square a value that has a radical and a number in front of the radical. All right, we know that's our c, by the way. Then we know these are our a's and b's right there, the two 12s. See what you can figure out. All right, now for our c squared, remember we have to square both the 12 and we have to square the square root of 2. And that gives us 144 times 2, or 288. That's the value of c squared. Now let's look at a squared plus b squared. A squared plus b squared is equal to 12 squared plus 12 squared. And that's 144 plus 144, also equal to 288, isn't it? So here we have a situation where c squared is equal to a squared plus b squared. So that makes this a right triangle, doesn't it? So we said, yes, it is a triangle, and in fact, it's a right triangle since c squared equals a squared plus b squared. All right, that's how you use the converse of the Pythagorean theorem. Simply, it's trying to determine, using the side lengths of a triangle, do you have an acute, an obtuse, or a right triangle? Very easy. See you next time, everybody. Thanks for watching.